Hello, in today's video I'm going to be talking about gravity and specifically looking at orbits. And within orbits specifically looking at how to calculate the velocity. So one can apply their knowledge to gravity and circular motion to find the velocity of any circular orbit. So I'm going to go ahead and draw a figure that will help us visualize this. So we've got our orbit here, and then we've got our planet with mass in there, and radius r. Then we've got our other planet here, which is moving in with velocity like this, and force, gravitational force like that. I'm going to label this M2. Okay, so referring to Newton's second law and recognizing that the centripetal force of gravity, we can solve for the velocity. So we start off with, we know that the net force is equal to A times M, so mass times acceleration, which we can say, okay, so since we know that, we've established that, we can then say that the gravitation, which is equal to the gravitational force, okay? So we can also say that m squared v squared divided by r is going to be equal to g times m1 m2 over r squared, where g is the gravitational constant, m is mass, and r is distance, and v is velocity. And so we can solve for v, and we get, using simple algebra, solving and simplifying, we get g m1 over r. So this is the key formula to use when you want to calculate the velocity of any circular orbit. So now I'm going to go ahead and apply this to a real world example from an AP exam. So I'm going to go ahead and read the statement first. Also, I want to note that this is a 3-series problem for problems number 24, 25, and 26. Two satellites of masses m1 and m2 orbit a planet of mass m in circular orbits. The satellites travel in opposite directions with speeds v1 and v2 as shown in the figure above. Their orbital radii are r1 and r2 respectively. Assume that m is greater than m2, which is greater than m1. So I'm going to go ahead and draw the diagram up on the board here. Got planet here, m, then we've got orbit, another circular orbit, and we've got m2 here, moving at velocity 2, and we've got m1 here, moving at velocity 1, and we've got radius, I'm going to center this a little bit better. Let's see. Radius 1, and then radius 2. And we're given that we should assume that m is greater than m2, which is greater than m1. So problem number 24 specifically says the ratio of the speeds v1 over v2 is blank. So we're going to go ahead and use our formula that we have right here, and we're going to find what v1 and v2 are, and then divide them by each other. So v1 is going to be equal to the square root of gm over r1, and v2 is going to be equal to the square root of gm over R2. So essentially I'm just taking what we're given and applying it into this formula. So when we divide V1 by V2, we get the square root of GM over R1 divided by the square root of GM over R2, which if you simplify, which takes a little bit of time, so I'm just going to give the answer. If you simplify, is just equal to square root of R2 over R1. And you can do this really quickly. It's just using simple algebra. So we check if this response corresponds to any of the answers, and we find that it does to A. So we can conclude that the answer to problem number 24 is A. And again, this is a series, so I strongly recommend that you go watch problems number 25 and number 26 after this video. Thank you.